Hello everyone, Namaskar, welcome to Maths Guidance and welcome to the second lecture of chapter 7, that is triangles. So far we have discussed the introduction of triangles and congruence of triangles. So in the second lecture we are going to discuss the criteria for congruence of triangles like SAS congruence rule, that is side angle side congruence rule, also ASA angle side angle, and AAS, that is angle angle side congruence rules. So we will understand it and we'll see the proof and also we'll take some problems. So please stay connected with my channel and please watch my videos and please like, share and subscribe my channel. Thank you very much. So friends, let's understand the criteria for congruence of triangles. Okay, let me first draw two triangles of sides. Let us suppose this side is 3 centimeter, this side is 2 centimeter, and this side is 4 centimeter. And let us draw another triangle in which one side is equal to this. Let us suppose this one. Let us suppose this is 3 centimeter, this is 1 centimeter, and this is 3.5 centimeter. So are these triangles congruent? No, these are not going to be congruent. So if one side is equal, then the triangles are not congruent. This is what we understand. If only one side is equal, then the triangles are not congruent. Now let us take another example. Here we are taking like this. Here we are taking that this side is 3 centimeter and this angle is, let us suppose, 60 degree. Let us name it A, B, C, D, E, F. Okay, here also A, B, C. So this is 3 centimeter, this is 60 degree. Now another one we are taking that this is 3 centimeter, this is 60 degree, and like this 60 degree, D, E, F. So if you observe, you can find that this is also not going to be congruent. If one side is equal and one angle is equal, then also it is not congruent, because this side can vary, this side may vary. If this is here 4 centimeter, it may happen here 5 centimeter. Alright, so this is also not equal, not congruent. Now let us take one example like this. Let us take one example. A, B, C, this is 4 centimeter, this is 50 degree, this is 2 centimeter. All right, D, E, F, this is 4 centimeter, this is 50 degree, and this is 2 centimeter. Now what we have, two sides are equal and the angle included here, that is also equal. So here you can observe that these triangles are congruent. So minimum we should have two sides equal and the included angle should be equal, so that the triangles are congruent. So this is the rule. This is called the SAS congruence rule. SAS congruence rule. And what does it say? That two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. Okay, let's write it. Two triangles are congruent if two sides and the included angle are of one triangle are equal to two sides and the included angle of the other triangle. So two sides and the included angle. So these three things has to be equal, then and only then the triangles are congruent. Okay, and with the previously known results we cannot prove this thing, so this has been considered as an axiom. So this is called axiom. Okay, so it has been assumed as universal truth because we don't have the proof. So this is called the SAS congruence rule. Side angle side, two sides and the included angle. Okay, it has to be equal, then the triangles are congruent. Then later on we will see some more rules that with which rules the triangles are congruent, but this is one of the rules, SAS, and this is taken as an axiom. Okay, so here this angle B is equal, angle B equal to angle E equal to 50 degree, AB equal to 2, AB equal to DE, and BC equal to EF. So what we get? AB equal to DE, angle B equal to angle E, and BC equal to EF. That is why it is SAS, congruence rule. The angle is included, means between these two sides the angle, two arms are these between the angle. Okay, now let's move on. Let's see another thing. Now let's first solve this question. This is based on the whatever we have read just now, SAS congruence rules. Okay, the question is like this: AB is a line segment and line L is its perpendicular bisector. If a point P lies on L so that P is equidistant from A and B. Okay, we will solve it. AB is a line segment. Let us first draw. Let us suppose this is AB. AB is a line segment. Okay, and line L is its perpendicular bisector. So it is like this, perpendicular bisector. Okay, let us suppose it is meeting here at C, point C, perpendicular bisector. If a point P lies on L, suppose this is the point P, it is lying on L, then so that P is equidistant from A and B, means this distance and this distance are equal. So let us first join these 2 points. Alright, so let us first write is what is given. Given is, okay, this is perpendicular bisector, so these two angles will be 90 degree. So given, and this also bisector, so AC equal to BC. Given is AC equal to BC and angle PCB both 90 degree. Angle PCA equal to PCB is equal to 90 degree. Okay, and we have to show that PA is equal to PB. PA is equal to PB. This is what we have to show, or we have to prove. Now let us see its proof. We will take these two triangles, PCA and PCB. So we will write like this: in triangles PCA and PCB, we want to make these two triangles congruent. Okay, we want to show that these triangles are congruent. So in triangles PCA and PCB, AC equal to BC, AC equal to BC, this is given. Also this angle PCA equal to PCB equal to 90 degree. This angle PCA is equal to angle PCB, this is also given. Also this PC is common to both the triangles. PC equal to PC, it is common. So what we see? SAS. By SAS, these two triangles are congruent. By SAS rule, triangle PCA is congruent to triangle PCB. And when these two triangles are congruent, we can directly say that PA equal to PB. So PA equal to PB. Corresponding parts of congruent triangles CPCB. Corresponding parts of congruent triangles, in short CPCT. CPCT we say, corresponding parts of congruent triangles, CPCT. So this has been proved with the rule what we have studied, SAS. By SAS rule this has been proved. Okay, now let's understand one more thing, that suppose you have been given two triangles like this. Two triangles like this. This is ABC and this is D, E and F. Sides are here 5 centimeter, 3 centimeter, and this angle is 50 degree. Okay, here this angle is 50 degree and these sides are 5 centimeter and 3 centimeter. Means sides are equal, means two sides are equal and one angle is also equal, like in the case which we have studied in SAS. Here SAS, two sides are equal and one angle are equal, but the angle was included. Okay, the angle was included angle. Here the angle is not included, so basically these sides are equal, angle is here, these sides are equal, angle is here, so angle is not included. If it was here, then we could easily said that these two triangles are congruent, but in this case if you observe, you can say that these are not congruent. So these triangles are not congruent. So this criteria means SSA is not going to work. SSA or ASS will not work in the congruency, will not work. Only SAS will work. SAS rule will work. These are not congruent, not congruency rule. Alright, this is correct, this is not. So by example I have shown you that SSA or ASS is not going to work. It does not hold true. ASS or SSA. So no need to remember these things. Only SAS is the right rule. Now we will see later on. Let's move forward. Okay, we will see some other rules. All right. Now this is also one criteria, ASA congruence rule. ASA means two triangles are congruent if two angles and the included side of one triangle are equal to two angle and the included side of other triangle. That means if you see, let us draw a small triangle here. ASA means this angle, this side and this angle are going to be equal, then this rule will apply. Okay, A, B, C and D, E, F. Suppose this is 3 centimeter, this is also 3 centimeter, this is 60 degree, this is 50 degree, this is 60, this is 50. So in this case the two triangles will be congruent. Alright, but we can prove this congruency rule. So this is considered as a theorem. So it's a theorem and we will prove it now. Two triangles are congruent if two angles and the included side, these are the two angles and this is the included side of one triangle are equal to another one. So we are going to prove it. So proof, let us see the proof. Here three scenarios are going to arrive. Okay, here three cases. Here let us discuss three cases. I am telling you all the three cases. three cases. So case one is case one when we have been given these two triangles, A, B, C, D, E, F. This angle B equal to angle E, this angle C equal to angle F, and this side is equal. Alright, this is what we have been given, like this. So the first case is when this side AB is equal to DE. First case we will assume this AB equal to DE. Second case we will assume when this AB is shorter than DE. Okay, this is smaller than DE. And the third case we will assume when this AB is larger than DE. Okay, when first case is these two sides are equal, AB equal to DE. Second case when this is bigger than this. Third case when this is smaller than this. So we will discuss all the three cases, and we are going to achieve this proof. We are going to achieve this proof. Okay. So if you consider these two triangles, in triangles ABC and DEF, in triangles ABC and DEF, first of all, angle AB equal to DE. First of all, let us write first this one, AB equal to DE. This is we have assumed. All right. Second one is this angle B equal to angle E. Angle B equal to angle E. This is given. And third one is this side. This side is also equal. BC is equal to EF. This is also given. So by SAS rule, we can say that triangle ABC is congruent to triangle DEF. Alright, by SAS, since we only know this thing, SAS rule, so we can say it that ABC is congruent to DEF. So the case 1 has been proved. Case 1 has been discussed. Case 1 when this AB equal to DE. Now let us discuss case 2. Okay. Case 2 is when AB is greater than DE. When AB is greater than DE. So here it will be like this. AB suppose this is A, B, C and D, E, F. Angle B, angle E, angle C, angle F. This BC equal to EF. Now let us construct one thing. Since this side AB is greater than D, we will take a point P here, P, so that this PB is equal to DE. Alright, we will join it like this. We will take a point P on AB such that PB equal to DE. PB is equal to DE. We are taking a point P. Somewhere in AB. Taking a point P on AB. Such that this PB is equal to DE. Because we have assumed that this AB is greater than DE. Alright. So we take a point P so that PB is equal to DE. Now in triangles PBC and DEF, this is equal to this, PB equal to DE, PB is equal to DE, angle B equal to angle E and BC equal to EF. So by SAS criteria, SAS rule, we can say that triangle PBC is congruent to triangle DEF. Up to this it is clear. Triangle PBC, this triangle PBC is congruent to triangle DEF. Okay. Now if these two triangles are congruent, we can say that this angle PCB is equal to angle DFE. Okay, angle PCB is equal to angle DFE, that is because of CPCT, corresponding parts of congruent triangles. PCB equal to DFE. But we have been given that this angle ACB is equal to DFE. We have given this thing, but we have angle ACB is equal to angle DFE. So from here angle PCB equal to DFE, let us suppose this is 1, and from here angle ACB equal to DFE. So we can say that, we can conclude that angle PCB is equal to angle ACB. PCB equal to ACB, but this is contradictory. These two angles cannot be equal. This is not possible. This is only possible when this P coincides with A. Alright, but this is contradictory. This is not possible. This is not possible. This is only possible when P coincides with A. Only possible when P coincides with A. That means AB equal to D. That means AB equal to D, and when this AB equal to D, that means AB equal to D, and when this AB equal to D, then we can directly say this side is equal, this angle is equal, this side is equal. By SAS, this triangle ABC and DEF are congruent. So triangle ABC is congruent to triangle DEF by SAS rule. So this was case 2, and case 3 is similar. When AB is less than DE. When AB is less than DE, so that it will be like this: ABC DEF. So we will extend this thing. We will take a point P here. Now we will do the same thing, same proof we will do, and we will come to a conclusion when we will have to say that this point P coincides with point A. Likewise in this case 2, and from that we can say that triangle ABC is congruent to triangle DEF. So I hope this is clear. This was a lengthy proof, but you will have to understand this. Case 1 is alright. Case 2 we have to understand when AB is greater than DE. So we take one point P such that PB equal to DE. Now we prove these two triangles congruent by SAS rule. So we come to a point where it looks like contradictory. This angle PCB equal to angle ACB. It can happen only when this point P coincides with A. So finally we come to the decision that the point P is here on A. So these two triangles are congruent. Alright, and this third case, third case is like this: this AB side is less than DE. So we take a point P outside of this line. If we extend this line, so we take a point here, and we again will come to the same conclusion. This is only possible when this point P coincides with A. So this is how we prove this theorem. Okay, now let's move on. This is an important proof of the theorem. You will have to understand it. Alright, now let's understand one more thing. This is AAS congruence rule, that is angle side. Right now we have discussed what we studied was ASA, angle side angle, and there the side was included between the angles. So two angles and one side was included. Here AAS says that two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal. Means it is not necessary that, let us draw two triangles. It is not necessary that this angle and this angle and this side, included side, only if the three are equals, then the triangles are congruent. This is not necessary. Any two pairs of angles and one pair of corresponding sides. So let us draw another one. This, suppose this angle and any side, this angle and any side, this side. If the side is not included, then also it can be congruent. This is what this rule says. Side need not be included. So it is congruent if any two pairs of angles and one pair of corresponding sides are equal. So the side not necessarily to be included, not necessarily the included side between the angles, the included side between the angles. Likewise, we discussed the earlier case ASA. In ASA, the side was included side between the angles, side was included between the angles. But if the side is not included, then also it is congruent by AAS rule. Okay, two angles are equal and any pair of corresponding sides are equal, then also the triangles are congruent. This is what AAS congruence rule speaks. Okay, now let us see one more thing, that the congruency of triangles depend on if all the three angles are equal. If all three angles are equal in two triangles, then it is not necessary that those two triangles are congruent. Okay, so congruency does not depend on all angles equal. There must be one side equal. So there must be one side equal. There must be any side equal. So this is not necessary, not sure whether the triangle will be congruent or not. Not sure congruent if three angles are equal. So one side, there must be one side equal, then and only then the triangles can be congruent. So this is one important information, because with all three angles equal you can draw so many triangles and all those triangles cannot be congruent. You can draw a triangle of like this because the angle is same. This is 90 degree, this is some 45 degree, let us see. This is also equal. So it can be of different sizes. All right, it cannot be congruent also. So this criteria cannot fulfill the congruency of triangles. Only all the three angles are equal, then this cannot be congruent triangle. So there must be one side equal, otherwise it cannot be congruent. So this is an important rule. Okay, all right. So friends, we have studied the congruence criteria for congruence of triangles. SAS, side angle side criterion, also ASA, angle side angle, and we saw its proof. It was a lengthy proof based on 3 cases, but we did it in a very good manner. We understood it. ASA, congruency rule, and then we saw that AAS, angle side, if the side is not included, then also the triangles can be congruent. So all these cases we have studied, all these rules we have studied. The only pending thing is the problem solving. So later on in the next video we will do it, since this video is lengthy, almost 26-27 minutes. So we will do it in next video. So please stay connected with my channel, with my videos, and I hope you are liking my videos. Thank you very much. In the next video we will see some problems based on these theorems, axioms. All right, thank you.